A Japanese professor captured this remarkable image of a Boeing 747 hit by lightning just after takeoff.
Most of the lightning strikes occur from extremity to extremity. So the lightning strike can occur at one end of the airframe. The current is passed through the airframe and exits the other end or out a wingtip.
Odds are high that every U.S. airliner will be struck by lightning once a year. But no U.S. plane has crashed because of it since 1962, when a spark caused gas fumes to explode. Part of what protects many airliners is simply that they're made of aluminum, a very good electrical conductor that keeps a majority of the electric charge flowing on the plane's exterior, then into the air. Everything inside, including the passengers, remains safe. A researcher at Boston's Museum of Science demonstrates this principle using a Van de Graaff generator to simulate lightning's shocking power.
It's called the skin effect because as long as I don't touch the outside of the cage, I'll be perfectly safe even as it's struck with over 1.5 million volts and a lethal amount of electrical energy.
But that doesn't mean airliners are free and clear.
It basically can affect any of the electrical systems in the airplane and cause the airplane to do things that the pilot's not telling it to do. And if you're at 35,000 feet, that's not a big deal, a little hiccup here or there. If you're, 50 or 100 feet off the ground coming into land, you get struck by lightning. It could easily put the airplane into a dive and put it into a very bad situation.
DNB Engineering is a leader in lightning technology and houses one of the world's most sophisticated lightning simulators.
We did a 200,000 amp high current test, and as you can see, we did some significant damage to it.
Delivering blasts of over 1 million volts or 200,000 amps of current. DNB's simulator provides invaluable data to those who create lightning countermeasures. That includes the makers of this seemingly simple tape, the most effective means to protect a plane's eyes and ears. It's radar.
What we want to do is intercept those lightning strikes. We place our device on the surface of the radome, and we place them around the antenna that's inside it.
When the lightning's initial electric charge hits, it races through the radome toward the radar inside. Gaps in the tape's patterned copper surface cause the electric spark to jump from one gap to the next. Once all the gaps are closed, a complete ionized channel is created, through which the remainder of the electric charge passes onto the plane's exterior, then into the air.
One way you can look at it is like your heart. You have a rib cage around your heart, and you have the ribs surrounding your heart. Well, our diverters are placed around that radar system inside there, and it serves the same purpose.
Here, tests at DNB proved the tape's remarkable effectiveness, as multiple blasts of 100,000 volts of man-made lightning are diverted along the tape. DNB engineers use every precaution to protect themselves from electric shock. And so should you.
It's simple stuff. Pay attention when thunder roars, go indoors. Boom. Pay attention to the weather and react.